Imagine a world where humanity never discovered fire. Not fire for warmth, not fire for cooking, not fire for protection, nor for crafting, nor for light. Imagine a humanity that grew up in the cold shadow of the natural world, where night always meant darkness, where raw food always meant struggle, where predators always remained a threat, and where nature never surrendered even a tiny fraction of its power. To begin this journey, we must return far into the past, to a time before humans existed as humans. A time when the world was wild, harsh, and indifferent. A time when early hominins roamed forests and plains, shaped by the environment rather than shaping it. In our timeline, the discovery of fire changed everything. It was not a single moment, not a spark in the dark that suddenly enlightened all minds, but a process. A gradual, accidental chain of observations, experiments, and traditions. At some point, early humans learned to keep embers alive, to maintain flames, and eventually to create fire at will. But in this alternate world, that moment never arrives. Lightning still strikes. Forest fires still burn. Volcanoes still erupt. Flames still exist in nature, fierce and untamable. But for reasons buried in the flow of evolution, early humans never learned to tame them. Perhaps their environment never forced them to approach fire. Perhaps the first curious minds that might have experimented never did. Perhaps instinct, shaped by thousands of generations, leaned more toward avoidance than curiosity. Or perhaps the accidents that led to humanity's first sparks simply never happened. Whatever the cause, the result is profound. Our ancestors grow up afraid of fire, not drawn to it. They watch it from the safety of distance, as animals of the forest do, a force to be respected, escaped, and forgotten. And from that single divergence, a new world begins to form. Fire shaped the human body long before it shaped human culture. Cooking food allowed our ancestors to extract more calories with less effort. It softened tough plant fibers, neutralized toxins, and unlocked nutrients that raw diets could not provide. This caloric abundance fueled the growth of the human brain. But in this world, there is no cooking. Every meal is raw. Tough, fibrous, hard to chew, difficult to digest. Early humans spend much more time eating. Their jaws grow stronger. Their teeth remain larger. Their digestive systems adapt differently. The idea of a human brain, the massive, energy-hungry engine of abstract thought, becomes less viable. It still grows, but it grows slower. It grows at a cost. In our timeline, fire freed time. Time to think. Time to plan. Time to gather socially. Time to imagine. Here, that time is consumed by survival. Every calorie must be earned. Every meal is a battle with raw flesh or unprocessed vegetation. Early hominins do not develop the same cognitive leaps. They remain clever but not brilliant, social but not deeply symbolic, adaptive but not transformative. Night falls differently in this world. On our Earth, fire extended the day. People gathered around flames, shared food, told stories, bonded, and passed on knowledge. Entire traditions, myths, and family ties grew around the glow of embers. In the fireless world, night remains a boundary that humans cannot cross. Darkness belongs to predators, not people. Evening arrives, and the landscape becomes a realm of caution and retreat. Humans climb into shelters earlier. They hide rather than gather. They sleep earlier. And they wake at dawn because dawn is their only light. Without fire, there is no reliable warmth. Cold becomes a constant threat. Humans evolve thicker body hair. They migrate less frequently into colder regions. Many parts of the planet remain uninhabited, too risky without artificial heat. Tools still develop, but slowly. Stone can still be shaped. Bones can still be sharpened. Plants can still be woven, tied, and bent. But many materials that require fire, hardened spears, pottery, metal, bricks, never appear. Without pottery, the storage of food becomes limited. Without metal, tools plateau early. Without fire-hardened wood, weapons remain fragile. Without torchlight, caves stay unexplored. The growth of culture slows. Not stops, but slows. Humanity remains at a level of development similar to our early Stone Age for far longer. And yet, intelligence still grows, just along a different path. Rather than mastering fire, humanity becomes exceptionally attuned to nature. They learn to read weather patterns with precision. They develop advanced awareness of animal behavior. They become experts in tracking, foraging, and predicting seasonal cycles. Their senses sharpen in ways ours never did. Night vision improves. Hearing becomes more sensitive. Smell becomes more reliable. Evolution compensates where technology does not. Human communication still grows, though more slowly. Language forms, shaped by necessity and cooperation. Humans still band together in groups, share food, protect one another, and raise children. But without firelit nights, conversation remains limited to daylight hours. There is less time for teaching, less time for reflection, less time for the creativity that thrives in moments of rest. Cognitive leaps happen, but centuries later than they did here. Humanity still spreads, but cautiously. Africa remains the primary homeland far longer. The colder regions of Europe and Asia remain mostly uninhabited until much later, when humans evolved natural adaptations to cold that our species never needed. Perhaps thicker skin, perhaps denser fat layers, perhaps new biological traits that help retain heat. Millions of years pass. Humanity evolves, but differently. They build shelters from natural materials, but without fire, they cannot smelt metals or harden tools. Their shelters remain simple structures woven from branches, leaves, mud, and bone. Communities form, but they are small, scattered, and temporary. Without fire to clear land, agriculture develops differently or not at all. Foraging remains a dominant way of life. Nomadism becomes a long-term human strategy. And then, after an immense stretch of time, humans still reach the point where bigger ideas begin to form. They observe the stars. They track the passing of seasons. They understand migration patterns. Their communication grows sophisticated enough to share knowledge across generations. But without fire, there is no metallurgy, no ceramics, no wheels forged by heat-treated tools. Technological explosions simply cannot occur. To build civilizations, humanity needed storage, granaries, containers, vessels. Storage required pottery. Pottery required fire. In this alternate world, civilization takes a completely different form. Communities remain small. Families roam rather than settle. Knowledge spreads orally across many small groups with limited longevity. Large-scale societies do not emerge quickly. Humanity becomes a species defined by adaptation, not transformation. Cooperation, not construction. Awareness, not engineering. Their relationship to the environment becomes one of deep observation rather than control. They do not reshape landscapes with burning. They do not clear fields. They do not forge tools. They do not build cities. They do not craft written records. Instead, they become experts in living with the land rather than above it. But human curiosity does not disappear. People still wonder. They still question. They still imagine. They still seek patterns in the world. They still dream under the same sky, guided by the same pulse of the universe. After thousands of generations, they develop a form of wisdom not based on technology, but on survival and social cohesion. Their intelligence becomes more intuitive, less analytical. They navigate using natural landmarks. They read the behavior of animals with remarkable skill. They become one with the environment in a way we cannot easily imagine. But the world remains dangerous. Predators remain bold. In cold regions, winter kills many. Diseases spread more easily because food cannot be sterilized through cooking. Harmful bacteria in raw meat create evolutionary pressure that reshapes human digestion. Perhaps humans evolve stomachs closer to scavengers, more acidic, more adaptive. Bones break more easily because no tools are strong enough to shape strong shelters. Storms destroy villages. Floods wash away communities. Life expectancy remains far lower. The world is beautiful, but it is unforgiving. And yet, across tens of thousands of years, humans begin discovering new strategies. Stone tools grow refined. Knapping becomes an advanced art. Shelters grow more sophisticated, reinforced by clever design rather than fire. Fiber weaving evolves into rope making. Rope enables traps, snares, nets, and eventually structures. Humanity discovers leverage through wedges, pulleys, and tension. These inventions do not require fire, only ingenuity. Spear throwers emerge. Bone needles appear. Clothing becomes more advanced. Migration patterns shift. Slowly, humanity becomes more mobile. And with mobility comes trade. Groups begin exchanging materials, knowledge, and tools. Cooperation grows between bands. Languages diversify. Stories pass across regions, carrying lessons, myths, and warnings. Even without fire, the seed of culture grows stronger. But so far, we have only seen the early stages. The story of humanity in this fireless world has barely begun. What comes next is slower, more subtle, more organic, but no less meaningful. And now that the foundation is built, we can begin exploring how such a humanity eventually confronts new challenges. How do they survive cold seasons? How do they build societies without metallurgy? Do they ever discover electricity? Do they develop agriculture in a completely different way? Do they build cities from materials that exist only in nature? Do they ever reach a point where their technology, though different, becomes advanced in its own way? Humanity without fire continues its slow evolution through the ages, shaped not by flames, but by the rhythms of nature itself. The landscapes they traverse remain largely untouched by human influence. Forests do not burn to clear new lands. Grasslands do not expand through deliberate burning. The environment grows without human interruption, dense and wild. Over time, humans learn to coexist with this vast, living world. They study animal patterns with increasing depth. They learn which plants thrive in certain seasons. They map their territories with the precision of creatures who must rely entirely on memory rather than written records or crafted tools. Generations pass. The populations spread slowly across the continents, but their path is dictated by climate, abundance, and safety. They follow rivers and coastlines because water is warmth, food, shelter, and life. Inland expansion is more difficult, especially in colder regions where fire is absent. Some groups eventually evolve unique biological adaptations to cope with lower temperatures. Their skin becomes thicker. Their metabolic rate changes slightly. These changes are subtle but meaningful. They allow humanity to reach regions they once feared. But progress remains slow. In our timeline, fire gave early humans a shortcut. an external stomach for easy calories and a source of defense. In the alternate timeline, human bodies must carry the burden. Digestion is more intense, requiring stronger teeth, more robust jaws, and more complex gut bacteria. These adaptations take energy away from the brain. The human brain still grows, still becomes capable of abstraction and planning, but its growth curve is different. Creativity spreads through communities more gradually. Still, nature rewards cooperation. Small tribes remain tightly connected. Knowledge is oral, songs, patterns, and stories encode information across generations. Over hundreds of thousands of years, these oral traditions become complex systems of memory that serve the same purpose as written language. Humans develop rituals and repeating phrases that are easy to memorize and pass on unchanged. Large-scale storytelling appears, though not around a fire, but beneath the open sky or beneath tree canopies, where groups gather during daylight hours. These communal moments form the foundations of culture. As time moves forward, humans begin forming relationships with nature that differ from anything in our history. Instead of controlling the environment with fire, they develop a deep observational relationship with it. They read the movement of clouds, anticipate storms, locate hidden water sources, and track migrations with remarkable accuracy. Their spatial memory becomes more advanced than ours. Their ability to interpret subtle environmental cues becomes an essential skill. This sensitivity to nature eventually produces a kind of intelligence that is difficult to compare to ours. They may not create metal tools, but they understand ecosystems with a richness that makes every decision informed and intentional. Their interactions with animals become complex, not quite domestication, but something closer to partnership. Humans follow animal herds without frightening them. They learn which predators prefer which trails and use that knowledge to avoid danger rather than confront it. Predators, in turn, begin to evolve differently because they do not encounter humans wielding fire or hardened weapons. Some predators learn that humans are not threats and begin to treat them as another species in the environment rather than competitors. But even without fire, humans gradually become toolmakers of increasing sophistication. Stone tools reach new levels of refinement. With enough time and experimentation, humans discover how to use pressure flaking and other advanced techniques that existed in our world much earlier thanks to fire. In this alternate world, artisans of stone emerge, able to shape incredibly sharp edges and durable points through patient effort. Over tens of thousands of years, these tools allow humans to build shelters that are stronger and more insulated. They dig deeper into the earth to create semi-subterranean homes that naturally trap heat. Some groups create windbreaks, earthen walls, and layered plant-based insulation that keeps warmth in and cold out. Resourcefulness becomes humanity's most powerful adaptation. Cooking never emerges, but food processing does. Humans learn how to mash, soak, ferment, and dry plants. They discover fermentation completely by accident, perhaps from leaving fruit too long in water or in animal hides. Fermentation produces new forms of food with enhanced nutrition, allowing for new cultural practices around preserving and sharing food. This discovery becomes a turning point. Fermentation, soaking, pounding, and grinding raw foods create diets that are less physically taxing, freeing up a small amount of biological energy. Over hundreds of generations, this energy contributes to the slow expansion of the brain. Intelligence continues its ascent, even without the caloric explosion that cooking provided in our timeline. Humanity remains slower, but it is still moving forward. As populations spread into new regions, something remarkable happens. Humans adapt biologically in ways we never experienced. In colder regions, humans develop more efficient fat storage and unique metabolic traits. Their circulatory system changes slightly. Their fingers and toes become more resistant to cold. These changes take place over tens of thousands of years, but they become decisive advantages. Eventually, humans populate regions that would have been impossible without fire. Across the millennia, human groups evolve distinct cultures shaped by climate, geography, and ecological knowledge. Some groups in temperate regions become master trackers and hunters. Others near coasts become skilled fishers, diving and swimming with techniques refined over countless generations. Without boats made of heat-bent wood or tar, humans create rafts woven from reeds, vines, and natural buoyant materials. Travel along coasts becomes common. Further inland, groups learn to manipulate materials that don't require heat: bone, stone, shell, wood, sinew, and plant fiber. Bows and arrows appear much later in this world, but they still appear. They are made of flexible woods, carved and shaped slowly with stone scrapers. They are not as powerful as bows from our history, but they are effective enough for hunting medium-sized animals. These tools give humans a greater ability to secure food, strengthening their survival. The next major leap in this world comes from humans learning how to modify their environments indirectly. Without fire, they cannot burn fields to create new grasslands, but they can plant seeds by hand. They can tend to plants they find useful. They can encourage growth by removing weeds or spreading seeds after eating fruits. Agriculture emerges not as a revolution, but as an extension of gathering, quietly, gradually, gently. Over thousands of years, certain plants become more abundant around human camps. Humans begin to notice that these plants grow better near villages. They begin clearing small areas by uprooting shrubs instead of burning them. This process requires more effort, but it creates safer and controlled spaces for food. Domestication begins very slowly. Farming in this world does not require large fields. It emerges as small gardens, clusters of useful plants grown close to human settlements. Because storage solutions are limited without pottery, early agriculture remains small-scale. Humans gather seeds and tubers to replant them during the next season. Over time, they recognize which strains of plants are more resilient, more nutritious, or easier to process. Natural selection, guided by human preference, begins shaping crops, even without deliberate planting. Eventually, certain communities transition from purely nomadic lifestyles to partially settled ones. They create long-lasting dwellings made of earth, stone, and densely woven plant fibers. Settlements grow slowly. Human groups remain relatively small, dozens rather than hundreds, because managing large societies without advanced tools is difficult. Settlements expand horizontally rather than vertically. Instead of towering structures, the world becomes dotted with interconnected villages that blend into the landscape. Human conflict still exists, but it takes different forms. Without fire-hardened weapons, warfare is less lethal. Stone tools are deadly, but without explosives, metallurgy, or large-scale organization, battles remain rare and small. Conflicts are resolved more through intimidation, displays of strength, and negotiations than through widespread violence. Over centuries, peaceful cooperation becomes more valuable than conquest because the tools for conquest never evolve. Knowledge spreads through travelers, individuals who carry stories, techniques, and songs from one settlement to another. Over time, networks of communication form across continents. These networks are entirely oral, but they are vast. Human memory becomes the greatest tool for preserving information. Certain individuals specialize in remembering long sequences, histories, techniques, or maps. They form a class of wandering teachers, historians, and storytellers. The absence of fire means the absence of artificial light. Nights are dark. The stars shine with a clarity far beyond anything we see today. With so much time spent under natural skies, humans become keenly aware of celestial rhythms. They track lunar cycles, star positions, and seasonal patterns with precision. Astronomy becomes an early science, guiding migrations, planting cycles, and cultural rituals. Slowly, humanity's identity changes. They are no longer creatures striving to control the world through force or flame. They are observers, navigators, and interpreters of nature. Their intelligence becomes observational rather than industrial. Their innovations come from understanding natural materials, not transforming them. As time moves into what, in our timeline, would be the Bronze Age, humanity in this world moves into a different kind of age, one defined not by metallurgy, but by biological and ecological ingenuity. This marks the beginning of a new era, one where humans begin thinking beyond their immediate needs and envisioning larger structures, communities, cultures, and perhaps civilizations that grow not through fire, but through adaptation. And yet, one essential question remains. How far can humanity progress without harnessing the most basic form of energy they never discovered. As humanity slowly begins to form more stable communities, their relationship with the world shifts again. Without fire, their technology never transforms the landscape, but their understanding of the world deepens. Each generation inherits knowledge through long chains of memory. People learn which plants to cultivate gently, how to coax growth from wild landscapes without destroying them, and how to build homes that endure wind and rain. The idea of a civilization in this world does not emerge suddenly. It is not marked by stone cities, metal tools, or towering structures. Instead, it grows from accumulated wisdom, thousands of small insights passed down across countless generations. Humanity moves along a parallel path, different from ours, but equally rich in experience. Their settlements evolve into intricate designs formed entirely from natural materials. Instead of shaping clay with fire, they craft advanced earth structures using pressure, water, and time. They learn how to create foundations by compacting soil layer by layer, forming stable platforms that resist erosion. Walls are built from woven branches reinforced with mud, then layered with grasses and leaves for insulation. Rooftops are crafted from densely woven mats that repel rain and channel water into reservoirs. These homes do not last for centuries like stone buildings in our world, but they are more easily repaired. Communities engage in cycles of maintenance that become part of daily life. Instead of building monuments meant to survive for thousands of years, they build structures meant to be lived in, evolved, and renewed. There is no permanence, but there is continuity. Over time, populations grow. Communities cluster along fertile river valleys where food resources are reliable. These regions become centers of cultural exchange. Nearby villages share stories, tools, seeds, and techniques. Paths between settlements become well-traveled routes. People carry goods on woven carts and sled-like frames that glide over grass or dirt. Agriculture continues to grow, but it looks unlike the agriculture we know. Without fire to clear fields or metal tools to plow soil, farming emerges slowly. Humans cultivate small plots scattered between natural vegetation. They tend to patches of land rather than converting entire landscapes. In this world, farming complements nature rather than replacing it. This creates a unique ecological balance. Fields blend into forests, orchards merge with wild groves. Humans practice a form of integrated agriculture where useful plants grow among naturally occurring species. This approach leads to ecosystems richer in biodiversity than anything in our timeline. Humans live within nature, not in opposition to it. As food becomes more reliable, populations grow more stable. People have more time to think, to share stories, to explore their surroundings. Knowledge becomes increasingly specialized. Some individuals become experts in herbs, others in animal behavior, others in weather patterns. Groups of experts form early councils within each tribe, not leaders in the traditional sense, but advisors who guide decisions. Human society becomes collaborative by necessity. Without fire-based weaponry or metallurgy, power does not concentrate easily. Communities rely on cooperation rather than conquest. Conflicts still occur, misunderstandings, resource disputes, territorial tensions, but large-scale warfare never arises. There are no armies, no sieges, no empires built through brute force. Instead, influence spreads through knowledge, culture, and trade. Trade networks eventually stretch across continents. People carry shells from distant coasts, stone blades from mountain quarries, medicinal plants from tropical regions, and seeds adapted to colder climates. Each item carries stories, forging connections between groups who might otherwise never meet. As humanity's understanding of the natural world deepens, curiosity about the unseen grows. People begin to explore the idea of invisible forces, the wind, the pulse of the earth, the cycles of the moon and stars. They develop early sciences rooted not in laboratories, but in careful observation. Without artificial light, the stars become central to human life. The night sky is more than a backdrop, it is a living map. People track the shifting constellations, noting how they predict seasons, migrations, and weather patterns. Astronomy becomes the first advanced discipline of this world. Star watchers emerge, individuals who devote their lives to studying the heavens. They memorize the positions of thousands of stars and create mental maps passed down through generations. Over time, they develop early models of the cosmos, simple at first, but increasingly sophisticated. They may not write anything down, but their oral descriptions carry the precision of long observation. These astronomers eventually begin to notice irregularities, wandering stars, eclipses, comets, and meteor showers. The predictability of the night sky gives humanity its earliest sense of order. People begin to understand that the world follows patterns, and patterns can be understood. This realization marks a turning point. It inspires a new kind of curiosity, one not just about survival, but about existence itself. Communities begin carving symbols into stone, not with fire-hardened tools, but with carefully shaped flints. These symbols are the earliest form of recorded memory in this world. They do not yet represent a full written language, but they organize knowledge into physical form, marks that other people can interpret with the right teaching. The development of these symbols begins to accelerate the spread of knowledge. No longer limited by pure memory, humans start coding ideas into visual forms. These forms become increasingly complex. They represent directions, counts, seasons, and later, stories. This new way of recording thought creates a slow intellectual awakening. Humans begin to categorize the world. They separate plants by use, animals by behavior, landscapes by patterns. This is the beginning of a scientific worldview, emerging organically from necessity and observation rather than from technological ambition. As humans look outward, they also look inward. Without fire to transform the physical world dramatically, they turn their attention toward understanding themselves. They study how food affects the body. They experiment with herbs and develop early forms of medicine. They discover ways to treat wounds, reduce pain, and help the sick recover. Healing becomes a respected discipline. Herbalists and healers develop complex knowledge systems passed down through generations. They learn which plants act as antiseptics, which reduce fever, which can be used for anesthesia, and which can be toxic in certain doses. In this world, medicine advances earlier than technology. As communities grow larger and more connected, humans begin developing shared cultural identities. Languages diversify, then blend through trade. New dialects emerge. Music grows in complexity as humans craft percussion instruments from wood, shells, and hollow reeds. Dance becomes central to celebrations and rituals. Ceremonies emerge to mark births, seasons, hunts, migrations, and the passing of elders. Without fire, gatherings occur during daylight or under the brightness of the moon. Humans learn to plan events according to astronomical cycles, creating early calendars long before agriculture becomes widespread. Over time, the idea of a nation begins to form, but not in a political sense. Instead, groups of villages recognize themselves as part of larger cultural and linguistic families. They share ancestry, stories, and traditions. These early cultural regions become the closest analog to civilizations. Trade networks between these regions grow sophisticated. Humans use rafts to cross rivers and lakes, and large woven vessels to travel along coastlines. They invent sails made from plant fibers coated in natural oils to repel water. These boats are not as durable as wooden vessels shaped with fire, but they evolve through experimentation. Eventually, some groups begin exploring distant shores. They do not conquer or colonize, they exchange knowledge. The world becomes interconnected not by empires, but by relationships. It is during this period that humanity experiences its first major philosophical shift. People begin questioning not only how the world works, but why. Scholars in different regions start developing abstract ideas about nature, time, and existence. They explore the idea that life follows a cycle, that everything has a place, that the universe is a continuous movement of forces that can be understood. Ideas spread across continents at the speed of human travel. Over centuries, shared concepts merge, creating early systems of belief that shape how humans perceive the world. Some groups view nature as a living network. Others see time as circular. Others focus on harmony between groups rather than dominance over land. These beliefs shape social structures, Hierarchies remain minimal. Elders guide decisions but do not hold absolute power. Leadership rotates or is shared among individuals with specific knowledge. Human society becomes remarkably egalitarian by necessity. Without the ability to store massive surpluses of food, no one can accumulate excessive wealth or resources. Communities remain balanced. Cooperation is rewarded. Isolation is discouraged. As centuries pass, these cooperative networks begin to form something resembling confederations, groups of villages tied together by trade, shared rituals, and mutual protection. They coordinate food distribution during lean seasons, exchange knowledge during gatherings, and send representatives to discuss issues affecting multiple settlements. The seeds of government appear, but not through dominance or centralized authority. Instead, they emerge through consensus and mutual benefit. At this point in the timeline, humanity has spread across the globe. Populations are smaller than in our world. Without fire and without the agricultural boom that followed it, growth is slower, but they are widespread. Each region has developed unique cultural practices suited to its environment. In tropical zones, humans build sprawling elevated homes to escape floods and wildlife. In temperate regions, humans live in earth-embedded dwellings, using the ground as insulation. In colder regions, humans adapt with thicker clothing made from layered plant fibers and animal skins. Deserts are crossed using knowledge of shade, wind patterns, and underground water sources. Mountains are navigated through generations of mapped routes stored in stories and songs. Oceans are crossed using celestial navigation, watching stars with unmatched precision. Humanity becomes a species deeply connected to the world, not through dominance, but through understanding. Yet one major technological transformation remains unexplored: energy. Without fire, how does humanity eventually harness power? As the centuries pass, humanity reaches a stage where understanding alone is no longer enough. They have mastered their surroundings through observation, intuition, and memory, but something new begins to stir within their societies, a desire to influence the world in more subtle, reliable ways. Without fire, they cannot melt ores, forge blades, or create engines, but they can still manipulate the world through movement, pressure, leverage, and biology. The first meaningful shift comes from the mastery of materials that require no heat to transform. For thousands of years, humans have shaped tools through patient carving and pressure. Now they begin experimenting with the properties of certain plants, resins, clays, and natural fibers. Some plants produce sap that hardens into a natural adhesive. Others produce fibers that, when twisted in specific patterns, become surprisingly strong. Combined, these discoveries lead to a quiet revolution in toolmaking. Instead of crafting fire-hardened spears, humans create composite weapons, layered constructs of bone, stone, and sinew bound by powerful natural glues. These tools last longer and allow for more precise hunting. The development is slow, spanning hundreds of years, but it marks the beginning of deliberate material science. With more reliable tools, communities begin constructing structures of increasing complexity. Instead of simple shelters built from branches and mud, humans develop multi-chambered homes, reinforced walls, underground storage pits, wind-shielded courtyards, and water-catching systems made of woven channels. Settlement architecture becomes a field of innovation, where knowledge spreads through oral instruction and demonstration. The absence of fire continues to shape everything. Homes are never lit by flame, so their interiors are brighter, more open, designed to catch light through reflective surfaces or through carefully placed openings in roofs and walls. Humans learn to line the insides of dwellings with polished shells, stones, or reflective leaves, softly diffusing sunlight into shaded spaces. Night remains a time for rest, introspection, and quiet conversation. Human circadian rhythms remain closely aligned with the natural day-night cycle. Darkness does not terrify them, as it might have terrified our ancestors. They adapt fully to the night. Their eyes adjust. Their hearing sharpens. Communities design paths through settlements using the texture of the ground, so people can navigate by touch in dim conditions. Far from being a barrier, darkness becomes an integral part of their culture. While societal development progresses, humanity's intellectual development begins to accelerate in unexpected ways. The first major leap comes from the invention of counting systems. Primitive markers scratched into stone evolve into structured symbolic systems representing quantities, events, or ideas. These symbols are not letters. They are memory anchors, cues that help oral storytellers recall complex sequences of knowledge. Through them, vast oral libraries emerge, containing hundreds of generations of recorded information. These symbolic systems begin to resemble proto-writing. Not yet full writing as we know it, but a structured method of encoding knowledge visually. The second major leap arrives when humans begin investigating patterns of movement, not just of animals or seasons, but of mechanical motion itself. They observe how certain vines stretch under tension, how bent branches store energy, how rolling stones reduce friction, how levers amplify force. These insights eventually led to the creation of early machines. Simple devices appear first. Weighted pulleys made from vines looped around smooth stones. Spring-like constructs made from flexible branches. Rotary tools powered by hand or by human movement. Without metal, these machines are limited, but not useless. They allow humans to grind grains, lift heavy materials, weave fabrics more efficiently, and build structures that would otherwise be impossible with simple hand labor. In this world, engineering emerges not from metallurgy, but from biology and geometry. With improved machines and tools, agriculture evolves. Humans begin cultivating larger plots, using woven nets to shade young crops, trenches to redirect water, and hand-operated presses to extract oils and juices from plants. They develop natural fertilizers from composted vegetation, enhancing soil over time. Eventually, some communities achieve near-permanent settlement. They build villages with hundreds of interconnected homes, each part of a larger communal structure. Food is stored underground in cool dens, insulated with clay and stone. Water is gathered in large woven cisterns lined with sap and resin. At this point, humanity begins forming clusters of settlements, the closest analog to cities in this alternate world. These proto-cities do not have paved roads or stone monuments. They blend naturally into the environment, constructed from materials that breathe, flex, and integrate with the land. With increasing population density comes increased social complexity. Communities begin formalizing roles: builders, toolmakers, navigators, astronomers, healers, memory keepers, negotiators, explorers. Each role emerges organically as individuals with particular strengths pass their skills to apprentices. As coordination becomes essential, humans develop councils, gatherings of representatives from different families or villages who make collective decisions about migration, food distribution, conflict resolution, and seasonal planning. These councils are not governments in the hierarchical sense. They are consensus-driven, with authority based on knowledge rather than power. And in the absence of fire, no single individual or group possesses the capacity to dominate others. There are no fire-forged weapons, no metal armor, no rapid methods of destruction. Societies that grow more complex do so cooperatively, not through conquest. This is the first glimpse of a striking truth. Without fire, humanity becomes less hierarchical, less warlike, and more egalitarian. But even in such a world, challenges remain. Disease is one of the greatest. Without boiling water or sterilizing tools, humanity must find other ways to keep illnesses at bay. Over time, they evolve a detailed understanding of hygiene, washing with certain plants, maintaining clean living spaces, isolating sick individuals, and developing natural antiseptics from herbs and tree resins. Healing becomes a respected and sophisticated field. Without fire-based treatments, healers rely on medicinal plants, poultices, massage techniques, bone setting, and controlled diets. They become experts in understanding bodily symptoms and natural remedies. This knowledge spreads across continents, creating a global heritage of medicinal wisdom far deeper and older than ours. As thousands more years pass, humanity's intellectual curiosity leads to another major shift: the study of natural energy. Without fire as an early crutch, humans seek alternative sources long before our timeline ever considered them. They observe how wind shapes the land, how water erodes stone, how tidal forces move with predictable cycles. These observations compel humans to experiment. They build early wind devices, giant woven fans that turn slowly in the breeze. They attach these fans to simple mechanical systems to grind grain or pump water. In regions with abundant rivers, they craft rotating water wheels made from carved stone and woven frameworks. These machines provide consistent power for simple tasks. Humanity discovers renewable energy thousands of years earlier than in our timeline, although in primitive forms. With greater mechanical power, complexity increases. Weaving becomes more advanced, producing stronger fabrics. Tools become more precise. Large structures become possible: bridges of woven fiber spanning streams, elevated walkways connecting hilltop villages, long tunnels carved manually into rocky terrain using stone hammers and patient teamwork. None of this progress requires fire. It requires only time, cooperation, curiosity, and the slow accumulation of knowledge. Meanwhile, cultural development continues. Songs evolve into complex musical traditions. Instrument makers craft flutes from hollow reeds, drums from stretched skins, and string instruments from tightly twisted fibers. Music becomes a core component of social cohesion and celebration. With increased leisure time, people begin asking deeper questions about the world. Philosophy emerges organically: reflections on death, purpose, community, and the nature of existence. They ponder the cycles of nature, the patterns in the sky, the behavior of animals, and the flow of water. Without cities or empires to distract them, their inquiries remain grounded in the physical world, leading to practical insights rather than speculative dogma. As knowledge grows, humans begin constructing libraries of memory, collections of storytellers who preserve vast bodies of information. These individuals undergo rigorous training from young ages, mastering the art of recall with extraordinary precision. Entire histories, genealogies, agricultural techniques, astronomical observations, and medical practices are preserved in their minds. Their capacity for memory far exceeds anything common in our timeline, because in this world memory is the backbone of civilization. Eventually, some cultures develop systems of knot-based recording, ropes tied in specific patterns that encode numbers or sequences. Others use carved markings in stones placed along routes to record distances or events. These proto-writing systems continue to evolve over thousands of years until full symbolic language becomes inevitable. At last, humanity invents writing, but without ink, paper, or fire-baked clay tablets. Instead, they use carved wood, engraved stone, woven patterns, and natural pigments mixed into plant sap. It is a slow, methodical writing system, but it changes everything. Written knowledge can now travel farther than memory. It can cross mountains, rivers, and deserts. It can survive the death of a storyteller. It can accumulate across generations. This marks the birth of true civilization in a world without fire. And just as in our world, once writing appears, progress accelerates. Humans begin making long-distance maps of stars, coastlines, and trade routes. They develop complex mathematics based on geometry, cycles, and proportions found in nature. Scientific thinking emerges, guided by careful observation and recorded results. Communities begin planning multi-year agricultural cycles, breeding hardier crops through trial and error. They experiment with selective planting techniques, cross-pollination, and soil enrichment. Some regions develop comparable population densities to early city-states in our own timeline, though their settlements remain integrated with nature rather than dominating it. This world is now entering a unique era, one defined by machines without metal, science without fire, and civilization without destruction. But the greatest challenge still lies ahead. Without fire, can humanity ever cross the threshold into advanced technology? Can they create engines, chemical processes, medicine, architecture, and large-scale innovation without access to heat-based transformation? What does a fully developed global civilization look like in a world without flame? These questions guide the next stage of this alternate human journey, a journey into an unexpected future shaped by ingenuity, adaptation, and the slow, deliberate unfolding of knowledge. Humanity enters a new stage of development, one defined not by discovering fire, but by discovering principles. Across thousands of generations, patterns that were once intuitive become formalized. People begin to classify the world around them not only by experience, but by reasoning. The idea that nature follows consistent rules takes firm hold, spreading through trade networks and oral traditions. Communities now maintain designated places for learning, open-air structures built from stone and wood, arranged to capture sunlight during the day and reflect starlight at night. Here, elders, navigators, healers, astronomers, and artisans gather to teach young apprentices. Knowledge becomes a structured process, even if informal by our standards. As these learning centers grow in number and sophistication, humanity steps into something resembling an age of science. The first major breakthrough of this period comes not from chemistry or metallurgy, both impossible without fire, but from mathematics. Humans in this world have always been keen observers of number and pattern, the cycles of the moon, the counting of days, the transitions between seasons, the steps required to weave a specific fabric. Over time, these patterns crystallize into abstractions. Numbers become symbols. Symbols become systems. Systems become tools. Mathematics lets them see relationships across scales, between the shape of a leaf and the curve of a river, between the length of a shadow and the height of a hill, between the movement of stars and the changing of tides. These insights refine navigation, agriculture, construction, and long-term planning. In our world, mathematics was accelerated by writing, fire, and metal. Here, it is accelerated by memory, observation, and necessity. The next major development comes from improved machinery. Without metal, gears and shafts must be crafted from carved stone, bone, and dense hardwoods. The work is painstaking, but the rewards are extraordinary. Humans build water wheels with precise carved channels that rotate smoothly. They create treadmills and harness systems that use human and animal motion more efficiently. They develop rope-driven mechanisms for lifting heavy loads, allowing the construction of large communal structures. These machines spark a quiet revolution, enabling tasks that once required dozens of workers to be performed by a few. With time saved, people devote more energy to invention. This world begins to see early experimental science. Groups of thinkers devote themselves to solving specific problems, improving crop yields, understanding the flow of water, predicting weather patterns. Without fire or electricity, their tools are limited, but curiosity drives them to push boundaries. Weather becomes one of the first sciences to mature. Humans map wind patterns, study cloud formations, and create predictive models based purely on observation. Storm forecasting becomes surprisingly accurate. Regions prone to flooding build elevated settlements or divert water with carved channels and stone-lined reservoirs. Agriculture becomes increasingly refined. Instead of fields plowed with metal blades, humans use sharpened stones to create furrows. Instead of slash-and-burn techniques, they develop methods involving selective uprooting, guided seed dispersal, soil rotation, and symbiotic planting. They experiment with companion crops, plants that grow better together than apart. Over centuries, these innovations create stable food-producing regions capable of supporting populations that rival early city-states in our timeline. As populations grow, so does diversity in thought. Multiple schools of philosophy develop across different regions. Some emphasize harmony with nature. Others explore logic and reasoning. Others focus on observation and repeatable results. Long-distance travel becomes more common. Humans construct large vessels from tightly bound reeds supported by floating wooden frameworks. They navigate using the stars, currents, and migratory patterns of sea creatures. Without metal or fire, transoceanic travel is slower, but not impossible. Gradually, distant continents begin exchanging knowledge, goods, and traditions. It is during this era that humanity stumbles upon a new and transformative discovery: the principles of pressure and stored energy. For thousands of years, they've used bent branches as bows, vine tension as traps, and compressed fibers for tools. But now they study these phenomena deliberately. They measure how much force is created at different levels of tension. They construct larger devices, then smaller ones, experimenting with ratios and mechanical advantage. The culmination of this experimentation leads to an entirely new class of machines: spring-driven mechanisms, counterweight devices, and rotary systems that store and release energy in controlled ways. These mechanisms, combined with wind and water power, form the backbone of a unique technological age. One without fire, one driven by natural energy, refined mechanics, and deep observation. Buildings become more intricate. Multi-story structures appear, built with interlocking stones and massive woven beams that transfer weight through complex frameworks. Some communities create observatories designed to track the sun's movement with extraordinary accuracy. Others create water-operated grain mills, textile looms, and mechanical devices for lifting, rotating, or grinding. Science deepens alongside technology. Humans explore the properties of materials through testing, cutting, compressing, and soaking. They learn which woods resist water, which stones fracture predictably, which fibers stretch without tearing. They study how plants grow, how animals adapt, how diseases spread, and how the body heals. Healers in this world become pioneers of early biology. They study the body with precision and care, recording generations of observations. They dissect animals to understand anatomy, track hereditary traits in families, and test natural medicines with increasing control. Over time, entire systems of medical theory emerge, based not on superstition, but on empirical results. Meanwhile, astronomers push their field forward. They construct enormous stone circles and wooden frameworks aligned with celestial events. They track the precession of stars over centuries, building a detailed understanding of the night sky. Eventually, they develop early models of planetary motion that approach remarkable accuracy. Their societies become more structured, but not in the way ours did. Power never centralizes into kingdoms or empires. Without fire-fueled weaponry, conquest is difficult. Without metal, mass warfare is impossible. Without cities that rise far above their surroundings, there is no incentive for domination. Instead, regions grow organically into confederations, loose alliances of communities connected by trade routes, shared knowledge, and mutual protection. Texts carved into wood, stone, or woven into fabrics circulate widely. These carry mathematical formulas, agricultural techniques, philosophical ideas, and scientific findings. A global culture of knowledge sharing emerges. In this world, information is the greatest resource. This era is not without challenges. Disease remains a major threat. Natural disasters can devastate entire regions. Nomadic predators still roam. Extreme winters test the limits of human endurance. But humanity adapts, not through engineering that reshapes the planet, but through wisdom that navigates it. Eventually, humans begin exploring natural electricity, not through wires and circuits, but through observation. They witness lightning striking trees, causing reactions in plants. They observe how certain fish produce electric shocks. They experiment with minerals that seem to attract or repel one another. Slowly, they piece together early theories of invisible forces. Their understanding remains primitive compared to ours, but it lays the groundwork for a deeper curiosity, the desire to manipulate forces without fire. With each generation, they build on the discoveries of those before them. Machines become more refined, knowledge becomes more structured, communication networks grow denser, tools become more precise. Humanity stands on the threshold of a new era, one where they will attempt to achieve what seems impossible, a world-spanning civilization without heat, engines, or metal. But is such a world truly possible? The next phase of this timeline explores whether humans can develop advanced engineering, medicine, architecture, and global communication without the transformative power of fire. And if they can, what kind of society emerges at the far end of such a journey? This exploration continues in the next section, where humanity steps into an age of innovation that looks familiar in form, but utterly alien in substance. Humanity now stands on the edge of a world unlike our own, one built not on heat or flame, but on time, knowledge, cooperation, and the slow unfolding of discovery. Their civilizations are shaped by cycles of nature, not by the rise and fall of empires. Their tools are shaped by patience and precision, not by furnaces or forges. And their minds, sharpened by generations of memory and observation, begin to imagine possibilities that would have seemed impossible thousands of years earlier. The next transformation arrives when humans begin experimenting with biological processes deliberately. For countless generations, they have observed how plants grow, how animals adapt, how ecosystems maintain balance. Their agricultural knowledge is vast, but now they begin to move beyond observation and into controlled change. Selective planting becomes selective breeding. Selective breeding becomes full domestication. Domestication becomes early biological engineering through natural means. Humans identify plants that resist pests, survive droughts, or produce larger fruits. They crossbreed them with remarkable precision. Over centuries, they produce crops entirely unique to this world, species shaped not by fire-based agriculture, but by careful ecological stewardship. The same happens with animals. Without metal tools or large-scale enclosures, domestication relies on mutual benefit rather than force. Humans develop symbiotic relationships with certain species that naturally tolerate their presence. Some animals become guardians, others companions, others sources of food through eggs, milk, or shared hunting. This shift marks the emergence of what could be called a biotechnological age, one where humans learn to shape life itself before ever learning to shape metal or fire. Meanwhile, mechanical engineering continues to advance. Humans create devices made entirely from natural materials that perform increasingly complex tasks. They construct enormous water-driven machines capable of powering weaving looms, mills, and early factories. They create tension-based machinery that stores energy in braided ropes, flexible woods, and layered fibers. Through trial and error, they learn how to regulate motion with carved stone gears, bone pins, and braided belts. Eventually, they create something our world would recognize as early automation, devices that operate continuously using wind, water, or tidal forces. Without fire, these machines never produce the speed or force of our industrial revolution, but they do create a quiet, steady flow of energy that allows complex societies to flourish. Work that once required thousands of hands can now be done by a few. Labor shifts away from survival and toward creativity, study, and exploration. Humanity now begins to build dense settlements, proto-cities woven into landscapes rather than built above them. They are not made of concrete or steel. They are made of carved stone, flexible wood beams, fiber-reinforced walls, and enormous earthworks shaped by communal labor. These cities do not dominate the land. They merge with it. Trees grow among buildings. Gardens cover rooftops. Water channels snake through neighborhoods, carrying fresh water and turning wheels that power communal workshops. Pathways are soft, lined with woven mats or polished stones worn smooth by centuries of footsteps. These cities are quieter than ours, cleaner, more integrated with the rhythms of nature. They do not glow at night, they breathe with the darkness. Communication between distant cities becomes the next frontier. Without fire to fuel long-distance beacons or metal to produce rapid transport, humans turn to nature once again. They create relay systems, stone markers, trained messengers, coded knots, carved symbols exchanged through vast trade networks. Over time, these evolve into complex systems that can carry information across continents with remarkable speed. With increased communication comes increased unity. Ideas spread faster, innovations reach distant regions, shared philosophies help stabilize relationships between cultures. A sense of global identity begins to form, not imposed by empire, but grown through connection. At this stage, humanity begins contemplating the natural forces they have observed for millennia: wind, water, magnetism, electricity. They experiment with naturally electrified fish. They study minerals that attract metal-bearing stones. They explore the ways certain plants generate tiny electric pulses. Their understanding of electricity grows slowly but steadily, not through wires or circuits, but through probing the behaviors of natural materials. Eventually, they discover how to generate small electric charges using pressure, water movement, or the interaction of minerals. They create early electrostatic devices, primitive but functional. These devices power small tools, influence plant growth, or help preserve food. Electricity enters society not as a replacement for fire, but as its own distinct path, a technology shaped entirely by curiosity rather than by the need for heat. With electricity comes a new age of experimentation. Humans begin studying vibration, frequency, resonance. They learn how sound travels through different materials. They create instruments capable of producing pure tones used for measurement, communication, or healing. Music merges with science. Architecture merges with engineering. Biology merges with philosophy. Civilizations expand, not through mining or metallurgy, but through mastery of complexity. As centuries turn into millennia, the world begins to change. Humans grow increasingly aware of how their presence affects ecosystems. Their technologies rely on nature rather than resist it. They create living buildings, structures that incorporate vines, trees, and resilient plant species woven into their foundations. Their homes are not static. They grow and evolve with the seasons. Eventually, humanity develops a new form of writing, more compact, more abstract, easier to carve or weave. This script spreads across continents, creating a shared global language. Regional languages remain, but the universal script allows scholars, travelers, and merchants to communicate across vast distances. This shared system marks the beginning of global knowledge. Libraries form, not in buildings lined with shelves, but in vast courtyards where carved stones, woven records, and engraved wooden scrolls are collected, studied, and replicated. Knowledge becomes the currency that moves the world forward. From this foundation, humans begin tackling questions that would shape their future. How can they store energy more efficiently? How can they build stronger materials without fire? How can they heal illnesses that still claim lives? How can they understand the earth itself? The answers come slowly but steadily. In the absence of metallurgy, humans develop advanced composites, layered materials made from wood, fibers, clay, and plant resins that rival our early metals in strength and flexibility. Through careful experimentation, they engineer substances capable of spanning long distances, supporting heavy loads, and resisting natural decay. Architecture reaches new heights. Humans build towering structures of interlocked stone and plant composite beams, living skyscrapers shaped to withstand storms and shifting earth. They create long bridges across rivers and valleys using natural arch designs. They carve entire cities into cliff faces and underground caverns, illuminated by reflective surfaces and bioluminescent organisms cultivated in controlled environments. Bioluminescence becomes a critical innovation. Humans learn to cultivate glowing fungi, insects, and microorganisms. They design living lamps, glowing pathways, and luminous gardens. Night transforms into a gentle glow of natural light, not from fire, but from life itself. At this stage, humanity begins exploring the deeper mysteries of the earth. They study minerals not for smelting, but for their electromagnetic properties. They study plants not only for food, but for medicine, structure, and communication. They study animals not only for companionship, but for insights into evolution and behavior. And slowly, a new kind of science emerges, one that integrates everything humans have learned across tens of thousands of years. A science of relationships, cycles, networks, and living systems. A science that sees the world as interconnected rather than divided. Eventually, humanity reaches a point where their achievements rival our modern world in complexity, if not in form. They have advanced medicine through biological understanding. They have advanced engineering through mechanics and natural materials. They have advanced communication through writing, networks, and natural signals. They have advanced architecture through living materials. They have advanced energy through water, wind, biomechanics, and small-scale electrostatic processes. Their technology is elegant, sustainable, and deeply integrated with the world around them. They have not conquered nature, they have grown with it. And perhaps the greatest achievement of humanity in this alternate timeline is not a device, structure, or invention. It is a mindset, a worldview developed over countless generations, the understanding that progress does not require dominance, that intelligence does not require destruction, that civilization does not require fire. They become a species defined not by what they burn, but by what they learn. A species that builds without scarring the earth. A species that advances without overwhelming the world. A species that survives not through force, but through wisdom. For all the things they never created, metal, engines, furnaces, for all the paths of technology they never explored, they have built something else, something rare, something precious. A civilization that endures, not despite the absence of fire, but because of it.